Start in just a moment. A quick announcement. This was handed to me. The SDF Public Access Unix system is giving away free validated shell accounts to Hope 6 attendees. I say to telnet to sdf.lonestar.org. That's sdf.lonestar.org, and put Hope 6 as the reference to get a free account with web space, email, applications, and even Gopher space. There's also, yes, I'm just reading what is in front of me. There's also a talk on SDF Sunday at 1 o'clock in room C. If you have missed any of these discussions and panelists because you've gone off to have beer or there's two things going on at once, you can always buy DVDs where the t-shirts are. But since we're a little bit behind, let's kick it off with Fiber. It's Project MF.
Okay. I want to thank everyone for coming. I need to quickly just do a couple of sound checks, if you'll just bear with me for 30 seconds.
Yes, the USB thing.
I guess we should just do the real deal, right?
Let's do it.
Okay. Okay, what I'm going to do is I'm going to blue box. I'm going to do something that probably people have not seen in quite some time. I'm going to do it so you can see it. I'll explain it right afterwards, but I'm going to do it because it'll also give me a good opportunity to do a live check. What I'm about to do is use a whistle that famously was known as the Captain Crunch whistle. And actually, is Crunch here anywhere? In the audience? Oh, there he is, the man. As the story goes, John used this very whistle to signal 2600 hertz and seize trunks, basically. Trunks, for those not familiar in the audience, are the cables that link up telephone switches together. And back prior to the digital age, when, well, nowadays everything is packet switched and uses a digital signaling system, up until the very early 90s, here in New York at least, everything was still analog. Trunk lines linking telephone switches together actually used the frequency 2600 hertz to signal the idle or in use, essentially the availability of a trunk line. And what people could do using electronics or even a toy whistle in mimicking this frequency could essentially take control of a trunk line, and along with the proper tones, which are different from the touch tones that you would use at home, an actual different set of tones, which incidentally were published in a legendary Bell System technical journal back in the 70s, which ended up, I believe, in a university library. Is that right?
MIT specifically.
Yeah. And people embarked on building an electronic device to mimic these tones, and the rest is history. Essentially, a whole generation of people, this man to my right, Cheshire, as well as Captain Crunch, John in the audience, were instrumental in exploring the telephone network purely by sound alone. Back in the 70s and 80s, it was a very interesting experience to be able to program these switching systems, which by and large were electromechanical. By today's standards, they would look robotic, essentially. They had very large moving parts that were extremely noisy. And the relays and electromechanical crossbars in these switches were essentially controlled by these magical tones, which, as I just said, were leaked out via the MIT library through the Bell System Tech Journal that published them. Obviously, the Bell system was not intending on the general public finding out what these tones were. What ensued was sort of a combination of toll fraud on a grand scale, as well as sort of a whole telephone counterculture that developed around people building devices to make these tones. And without any further ado, let me play some of these tones, which some of you may never have heard before. That's the famous 2600 hertz. The whistle, of course, can make 2600 hertz much louder, which is great because sometimes you have a really lousy connection and you need to be heard by the remote switch in order to seize the trunk. What I will do right now, and it might take more than one attempt, is I'm now going to seize a trunk and place a call to someone in the audience. Is this person in the audience right now? Can he stand up and introduce himself? He will be receiving the test call. After the test call is made, and we've briefly conversed with David, I'm going to explain what just happened and what I did to make this possible once again. Because as I touched upon, this type of signaling is not used anymore except maybe in the most remotest of locations where digital switching has not yet been installed. There's also areas that I'm aware of where even though digital signaling is in place, they are still using MF signaling because they simply haven't modernized themselves yet and they need to be compatible with older switches that they're still communicating with. To my knowledge, no one is using 2600 hertz single frequency trunk signaling anymore. So I just had to recreate this in time for the conference. So here we are, we're going to have a demonstration, bearing in mind it doesn't always work the first time, and in reality, it didn't always work the first time either, so it's very realistic. Ultimately, the goal is we're going to be able to call David using the MF tones, and after we briefly converse with David, I'm going to explain what I just did, and then I'm going to explain the project of how I made this possible. What I'm going to do is I'm going to call a number which back in the old days would have been a number that was at least just beyond your favorite local tandem office, and I'll explain what that means in a moment also. Bearing in mind this is a complete simulation, I'm calling real phone numbers that are in the public telephone network over voice over IP. This whole simulation is made possible by modifications I've done to the Asterisk PBX.
I should mention, I think the Bell tried pulling that article once it was released and once they realized what problems it caused them.
Yeah, I think the damage was done by the time they realized that the tones themselves, the frequencies, had been leaked out.
Also, keep in mind that back in those days, electronics were very expensive. They didn't expect that the home hobbyist would be able to build the kind of oscillators required to produce tones of the purity required to get into the network and manipulate the network the way it does.
You know, my blue box, which you see here on stage, is relatively small. The reason for that is I'm actually using an MF synthesizer chip. You have to understand that the phone company themselves obviously didn't build these huge circuits and put them into blue project cases and tune them with little eyeglass screwdrivers. So back in the late 80s, I discovered chip that actually synthesized the tones. But here we go. That was a Wink supervision.
Welcome to
That was the
Verizon
answer
Voice
supervision.
Messaging Service. If you want
We're now
leave a
going to
message,
attempt to seize the
please dial
trunk.
the number of the person you are calling, starting with the A.
We have now seized the trunk. We're now going to signal.
The number you have
The
dialed
call did
is
not go
in
through.
service. Please
This
check the
often
number and
happens.
try again.
And we got dropped. This is actually the way that I actually programmed the trunk to work back in the old days would have been referred to as a goody tandem, because oftentimes you could remain on the trunk, and after you were done speaking to someone or key pulsing somewhere, you could actually seize it over again and get another wink back and dial another fresh number without having to start all over again. Sometimes that works, and sometimes the whole call clears. So we're going to do it one more time.
Welcome to Verizon's Voice Messaging Service.
Hey there.
Hello, David.
Am I getting charged for this? Nice phone number. All zero.
All zeros, yeah. See, the great thing about using voice over IP is a lot of the providers let you set your caller ID to whatever you want it to be. But that could be the subject of yet another talk. So, we just blue boxed a call to David in the audience. This should no longer be possible. How could it have been done? Let's explain what I did and how I got this idea and everything leading up to this point. Back around the end of last year, a website came to my attention called Phone Trips. And Phone Trips is a website that was put together by a gentleman who traveled around the country in the 70s with a reel-to-reel tape deck, who was just fascinated by all the different sounds that he heard when he placed phone calls. Now, this didn't have anything specifically to do with blue boxing, but he was just amazed by all the clicks and kerchunks and different rings and things of that nature, that he wanted to record them and collect them and basically archive them. The amazing thing is that 30 years later, he still has all these reel-to-reel tapes. And he digitized all these recordings, turned them into MP3s, and put them up on his website. As I understand, since I mentioned this in the brief summary of my talk on the HOPE website, the Phone Trips website has been overloaded with people downloading or trying to download the MP3s. Now, the thing that's interesting about this particular website is that amongst the many recordings are some actual recordings of a gentleman who referred to himself simply as Evan Doorbell. Obviously an alias, cannot possibly be his real name. But what he did was he took reel-to-reel recordings he had made of people actually blue boxing, himself and some friends of his, back in the 70s and probably early 80s. He took the reel-to-reel tapes and he digitized them in really high quality. When this came to my attention and I heard somebody actually demonstrating blue boxing in sort of a radio show format, which was really entertaining to me, he was describing what he was doing and sort of interviewing himself talking on the tape in the 70s, which was very interesting. It was sort of like a time machine, sort of. When I actually heard someone blue boxing, I just really sat back and I got to thinking, you know, it would be really cool if you could do this again. But obviously, you know, it really can't be done anymore because the phone system doesn't work that way anymore. So I'm thinking to myself, wow, how would it be possible if it could be done? And the wheels started spinning. And I'd been already playing with the Asterisk PBX, which for those of you who may not be familiar, is a free piece of software maintained by scores of people that's been under development for several years now. I had been using it for my own fun at home. It had come to my attention in reading through the source code that it actually is capable not only of producing MF tones, but detecting them as well. I didn't know how well this had been tested, but once I discovered that it was actually possible, I intended to find out how well it had been tested. The first thing I needed to do was just that. I needed to figure out a way to create a trunk that existed in my living room. Now, that probably sounds a little weird, but since nobody else was really helping me with this project at that early point, what I needed to do was figure out how could Asterisk be fooled into thinking that two endpoints of a trunk line were actually the same system, and it was the computer in my living room. Well, it also turns out that there is a feature in Asterisk that allows you to do T1 over Ethernet, which is extremely interesting. What I did was I set up 2 extra Ethernet cards in my machine, which incidentally right now is sitting in the server room downstairs, which we are actually connecting to with a soft phone and blue boxing out through it. Now what I did was I created a trunk line, essentially this T1 going over, a T1 with a voice channel bank, a 24-channel channel bank, with 2 sides, so we have 48 channels total, going over Ethernet with a crossover cable. Anyone in the audience who may be familiar, a channel bank basically works where even if you're not sending anything in your particular time slot, whereas if there's no audio to send, you're still sending something. So if you actually were to do this over the same Ethernet that you had data going over, your network would be dead, it would be killed, because the bandwidth utilization would be just so high. I found that out after taking out my home network several times. So it was very clear to me that I needed 2 dedicated Ethernet cards to serve as the 2 endpoints for the trunk and connect them up together over crossover cable. So great. Now I've brought this up in Asterisk. Now the next thing I needed to do was, rather than using, modern signaling, what I wanted to do is have it use, basically set it up to use as a digital channel bank, but do analog signaling over digital. Again, something that Asterisk should be capable of doing based on the code that I saw that was already written. And sure enough, using E&M signaling, rod bit signaling over digital, it was able to signal MF, which I was able to confirm by monitoring the trunk lines. So this was the first time I had actually personally heard MF tones being used to complete phone calls in probably, 10 or 15 years?
Yeah.
Yeah.
The odd thing about the Asterisk MF code is it was originally designed to be used on radio systems. And
Well, no, the SF signaling.
the SF signal.
Yeah, the SF signaling was, which I wanted to talk about that now. So it was obvious the MF zone signaling was included in Asterisk, obviously, for backwards compatibility with older trunk systems. Now the thing is that in order to make this blue boxable, since that was my ultimate goal, was to make it possible to seize trunks again, what I needed to do is figure out if, number one, Asterisk was capable of using single frequency trunk signaling, the so-called 2600 hertz tone, in order to signal the availability of trunk lines, namely my virtual trunk that I created. Now, it was apparent to me that Asterisk had the capability. As Walter had just said, it seemed that it was included because somebody, the original author in fact, was planning on using it for some odd reason to do signaling over radio relay. Now, why anybody would want to do 2600 hertz single frequency trunk signaling over radio is completely beyond me, but it did add to the complexity factor in getting this to work, because essentially the logic of everything was sort of inverted from what he had originally intended. What I discovered some months later in actually developing this whole project in my spare time is that the single frequency trunk signaling didn't really work. Obviously, it was a work in progress that did not have a very high priority on the author's part, from what I could tell. So I was basically on my own to get this working. The biggest challenge in getting this to work was that I knew that based on the way he wrote it, the trunking supervision was not based on timing in any way. And we needed it to be based on timing because in order for you to be able to seize a trunk without hanging yourself up, the whole system has to be based on timing. When I say timing, I mean that if 2600 hertz is present on the trunk beyond a certain threshold, it means that the call is hung up, essentially, in very simplistic terms. If you are able to make 2600 hertz through artificial means within that certain threshold, you'll basically keep the trunk off hook and make it ready to receive tones, tricking it into thinking that it's talking to the switch on the other end. Now, bear in mind, none of this really exists. All this exists as a simulation in my computer at home, running an Asterisk. So there were a lot of challenges in getting this to work. In fact, I only really just got it working about a week or two ago. Getting the trunk signaling, the timing to work was a real challenge. The original author actually wrote it in such a way that was incorrect. He completely threw away the timing factor in favor of what's known as wink start. And wink start basically doesn't care anything about timing of the 2600. It basically looks for the presence of winks, which are very short blurts of 2600, where it's only relevant if it hears a wink or doesn't hear a wink. This wasn't really conducive to the way I wanted to make the trunk work, because it's not the traditional way that trunks worked back in the old days. Basically, to summarize in brief, like I said before, the presence of 2600 hertz on a trunk meant that the trunk was not in use. When the remote end of the trunk wanted to use it, it would basically remove the 2600 hertz for a brief time, apply it again, and then remove it again. This was known as a kerchunk. The remote side would then remove 2600 hertz from the line completely and respond with another beep of 2600 hertz, signaling that it was ready to receive digits. That's what you just heard very quickly when I placed a call, seized the trunk, got the small little beep, signaled the MF tones, and we briefly conversed with David in the audience. Once I had gotten the trunk seizure working and the timing factor working and all these things, I was faced with a new problem, which was the sensitivity of the MF tones. Now, bear in mind, I'm introducing MF tones through pocket-sized electronic device of questionable clarity and questionable amplitude, because I'm basically feeding it through the microphone of a telephone, going over voice over IP, which is now being digitized, sampled, converted into SIP protocol, and sent through my phone system, and then converted into the proper format.
Yeah, well, what was it in the beginning? I think it only detected the 3.
Yeah, it was really bad, because if we monitored the trunk line of Asterisk itself placing the call out, we could actually hear it, the tones loud and clear that it was making. And of course, its calls went through every time, which was great, but all that did was prove that, okay, we got 2600 hertz signaling working, we got the MF signaling working, but we can't influence it in any way. And without the ability to influence it from the outside, well, that's what blue boxing is all about. If all we could do is listen to a phone system making the tones, all you have is basically, a really great simulator that you can impress Walter with. But seriously, the thing was to get it to allow us to inject the tones into the system and understand them and allow us to route calls artificially. Now, the thing again was sensitivity. And it turned out that in the MF detection portion of the Asterisk source code, bearing in mind every step of the way, I'm doing a lot of source code modifications to Asterisk, which I do want to mention I'm planning to make available to anyone interested. The whole point of this, obviously, is to share with people. I want as many people as possible to put these modified asterisk systems up so we could actually connect to each other and blue box to each other. Because basically, in the spirit of sharing, I obviously didn't do this with any monetary gain in mind. I can't imagine how I would make any money off this anyway. But I just thought it'd be really a lot of fun to make a total simulation of how the phone system essentially worked. You're probably noticing that I have really nothing on screen except us. The reason I did that is very interesting, but it has historical reasons. And that's that the first thing that I told Emmanuel when I had the idea to present this at Hope is that I wanted a blind person to be able to enjoy it. And the reason why I said that is very important. A lot of the counterculture that developed around exploring the telephone network through the use of these tones was done by blind people. And the main reason was because, I mean, we're talking in the 70s. There was no real personal computer revolution. This was a way that you could program something without being able to see it. This was a total network that spanned the entire planet that allowed you to program it using simple tones. Well, this is something a blind person understands that he can do. I mean, maybe somebody has to make the device for him, but once that's done, he's free to explore all he wants. So I thought it would be really interesting, maybe at some point, if there are any blind people around who are interested or maybe have heard about this from a historical standpoint, might want to get in touch with me after the conference. What I did do, I want to mention now, is I registered the domain projectmf.com. And while I don't have a website up there yet, I do plan to put up a message board where I will be making the source code modifications available and also allow us to discuss the project further. And I'd like to get as many people involved as possible who have experience not only with blue boxing, but also traditional telephony experience and even experience with Asterisk if possible, so we could continue the development of this project. Again, I'm doing this in my spare time. It has nothing to do with my professional work. And I'm just glad that I was able to get it to work in time for the conference and really bring it all together. What I want to do now is I want to turn the mic over to Cheshire, and I'd like him to describe the culture at that time, back in the 70s. Because when me and Walter were trying to revive real blue boxing back in the 80s, it was sort of a different culture going on because the computer revolution had already taken place. So really we had a combination of people who were hacking the phone network via computers and telephone switches and so on. And also we were trying to do the retro thing because we thought that the things that John did in the audience and Cheshire did were just really cool. The idea of being able to program a computer or a network through sounds alone just sounded like something we thought was just like awesome. And the fact that we could hone our electronic skills at the same time in order to construct devices like this, in order to perform this was really bringing together a lot of different disciplines. Programming, knowledge of telephony, knowledge of electronics. But again, back in the 70s, this didn't exist. There was like only this counterculture that existed around the electronics portion of it and the audio portion of it alone. So now I'd like Cheshire to describe what that was like in the 70s, just the whole blue boxing phenomenon.
Okay, putting me on the spot here. First, I'd like to backtrack a bit. MF stands for multi-frequency. SS, of course, single frequency. E&M was...
E&M actually came from ear and mouth, ironically. Ear and mouth signaling it had to do with the actual jacks that were plugged into the cord boards back in the days when, before telephone switches existed, where operators basically completed your call after asking you what number, please. Ear and mouth referred to the actual jack, the part that went to her ear and the part that went to her mouth. This type of signaling was obviously very crude, but it was a type of four-wire signaling which was carried over into the electromechanical signaling system, which sprung into existence, and it was simply shortened to E&M signaling. And this was initially used over short distance to signal the availability of trunks between central offices.
Okay, where to begin, really? I first started picking up a copy of Esquire magazine when I was stationed overseas. People knew I was interested in phones, and hey, Cheshire, have you seen this article in Esquire here? This was, of course, October 1973, the Secrets of the Little Blue Box by Ron Rosenbaum. And it was an article about an amazing little character named Captain Crunch and his adventures with a little whistle out of the cereal box, and the tone oscillators that he utilized as well. From there, I somehow heard about a small newsletter called TAP, which at the time was the Technological American Party. No, excuse me. No, before TAP was YIPL, the Youth International Party Line. Now, this goes back to the days of rural telephony, where you had one wire that ran down the road and it went off into each farmhouse, and everybody was on the one trunk line. It was a party line. If the operator rang rings of two long and one short, that was the Smiths. Two shorts and one long, that was the Joneses, and the other families along the party line. And you usually had to yell, because when the phone rang, everybody along the party would pick up and try and listen on the conversation as well. The Youth International Party was the Yippies, Abbie Hoffman and his crowd down on number 9 Bleecker Street. And the YIPL newsletter was formed by Abbie Hoffman and a phone freak who called himself Al Bell. It started as the Youth International Party Line to share information about telephones and telephone networks, and how the revolution could get free phone calls. Well, about a year or two into this project, Al Bell looks at his technical newsletter, sees all this political crap in it, and says, "What's all this political crap doing in my technological newsletter?" So he picks up his marbles, went up Broadway a few blocks, and set it up as TAP, the Technological American Party. Well, it turned out that it's very difficult at the time to open up a checking account with the word party in your name unless you were a bona fide political party. So it became the Technological American Program for official purposes. Let's see, then it got turned over to a phone freak from New Jersey called Tom Edison. By the time I moved to New York City and got involved in TAP, Tom was running the show. I may have actually been introduced to Al Bell once. I really can't recall. But the whole idea behind YIPL, behind TAP, was to share the knowledge. The information about how to crawl through networks, how locks worked, and how to explore the technology of your daily life. Everyone had a telephone in their home, even then. Now we carry them around in our pockets. We were the people curious enough to wonder how they worked, how we could explore those networks and play with them. The idea of playing with technology was just, something we thought was marvelous, and our folks thought, huh? Why would you want to do that? Go out and play. But we persevered. We found out more about what we like to do, and eventually started meeting each other. YIPL actually put on conferences. Before I moved to New York, I'd gone down to a conference YIPL had put on in the Diplomat Hotel in New York City. I believe that was 1973 or 4. And it was an anarchistic free-for-all. If you want to talk about this, go to that corner of this large ballroom. If you want to talk about that, go to that corner of the big ballroom. This other thing over here in the other corner. And of course, you'd go, listen for a bit, get bored, go to the other corner, meet somebody in the middle, start talking. It was a great free-for-all, free-form kind of environment. And we shared the knowledge. Somebody knew this about that little bit of the network, and somebody knew that about the other. and we just started talking with each other. A few articles came out of it, I'm sure. What we could, we put into TAP. We kind of borrowed a line from the New York Times and changed it to our own devices. TAP was all the news that fit. We had a specific format, and if it fit in our magazine, it went in. It was a lot of camaraderie through the post. You know, it was sent through the mail, and our readers were just rabid. They loved our stuff, and you know, I still collect much admiration to this day just because I helped to publish the damn thing. And they were fun times.
Is it true that the TAP newsletter was that the first place in print that plans to build a blue box were published?
I honestly couldn't say for sure.
But it's very possible.
It's very possible. It was, you know, strictly oscillators. You needed 7 oscillators for the 7 frequencies, and then a matrix array for the buttons to press them and what have you. The way I like to explain it is that your touch-tone telephone at home puts out a certain set of frequencies. If you had asked the operator to place a call for you in those days, the operator's dial put out a different set of frequencies that directly controlled the long lines network, and the blue box duplicated the operator's frequencies. And that's my short form on how a blue box works.
These are the MF tones that the box makes.
We refer to the MF tones for those operator's frequencies to separate them from the touch tones, formerly a registered trademark, which the touch tones being in your phone, but touch tones were also multi-frequency tones. We just use those designators. And I have gone up on USPTO.gov, the U.S. Patent and Trademark Office, with all the shenanigans of AT&T changing hands, dying, being reborn with SBC, and buying up a few more things. The trademark touchtone is no longer owned by AT&T. So I found that.
Does that mean it's not owned by anyone at all?
I don't believe it's owned by anyone at all.
Emmanuel should trademark it, actually. That'd be great.
Yeah, it could get interesting, but
Yeah.
then what would we use it for? So you no longer have to put a little circle R after the words touch tone in articles and what have you.
So now I have a question for you. Were you involved in, there were some of the, they weren't really conference bridges, but they were like, for example, always busy numbers that bridged a lot of people together.
I used them back in those days. I had no responsibility whatsoever for setting them up or anything.
Sure.
I really never had my own blue box. I visited John on the West Coast once, and he gave me a demo. When I was living in upstate New York, a fellow let me borrow a blue box, and I placed 3 telephone calls. The first was to 303-499-7111, the National Institute of Standards time signal in Boulder, Colorado, which I like to listen to on shortwave as WWV. Then I used the knowledge I'd picked up out of the Yipple newsletter and some other stuff I'd read. I got to the White Plains sender, and from there to the teletourist recording in London, England. So I finally proved to myself, yes, this stuff really does work. Then, keep in mind this is the 70s, I dialed directory assistance, 910-555-1212. Now today, 910, I believe, is a North Carolina area code, but then the X10 area codes were called special area codes, and in fact were part of the Twix Teletype Network, TWX, Teletype Writer Exchange. Oh, and this is a completely separate network from the telephone system. Yeah, right. 910-555-1212, the directory assistance number for teletype machines. I heard it ring, click, the modem tone of a Bell 103 modem for Twix teletype machines. I knew it was interconnected.
So the interesting thing that's worth mentioning about blue boxing is that you had access to dial and reach a lot of numbers that you simply couldn't reach by direct dialing through your normal telephone. There are a lot of numbers that would be considered invalid if you dialed them that way that you were now able to dial. There were entire telephone networks that you were able to reach via blue boxing that you wouldn't be allowed to dial ordinarily. The Twix network is one. There was other networks like Autovon that were used by military and things like that. All sorts of private telephone networks that were actually bridged together with the public telephone network, either directly or indirectly, were now reachable. And the thing I want to mention also in bringing up my Asterisk system, Asterisk allows you to be very free-form in what it calls extensions. Extensions essentially could be considered routing codes. If you are on a traditional telephony switch, you would define office routes or routing codes, and you would basically define them to go to internal things, test numbers, and so on and so forth. What you heard earlier, which was a really loud, obnoxious tone, was a 1004 hertz tone, which was traditionally used to measure signal-to-noise ratios. And this was known in telephony jargon as a milliwatt test. And I actually mimicked that by creating that on routing code 102, because back in the old days, you used to actually seize a trunk and key pulse 102, hit ST, and you'd get a 1004 hertz tone. The thing is that you can really recreate a lot of these old routing codes and things really to your heart's content using Asterisk. And I thought it'd be really cool if we get some people to bring up some of these switching systems, completely as simulations, have them talking to each other, basically bridging them to the public telephone network over voice over IP, which is essentially what I did. So it looks like you're actually making a traditional call over the public switch telephone network and getting 2600 hertz supervision when you connect to it, and being able to blue box it from there, and also being able to do that in reverse, dial in from the outside. So this is something that hasn't really been possible in a very, very long time. Now, what I'd like to do is take some questions from the audience.
Anyone out there have a blue box with them?
Anyone out there in the audience with a blue box besides me up here?
Not I.
John, you're at the microphone. Go ahead.
Yeah, John, please.
Not I. I don't have a blue box. They're still illegal. You might be interested to know that on the 18th of June of this year, the last N2 carrier went belly up. I believe it was an independent phone company somewhere in the Midwest that basically, Warwinia, that's it. Yeah, that's it. And so I was invited to get on the conference call and make a blue box call. Of course, I gratefully declined. They're illegal still in California. Earlier, you were talking about the O codes. I'd like to elaborate a little bit on that. If you wanted to call Stockton operator, you dial 209-121. You'd actually open with a key pulse, KP 209-121 start. That would connect you to the Stockton operator. But there are other cities in the 209 area code at that time. There was Modesto, and there was also Fresno. For Modesto, you dial 209-044-121. For Modesto, you dial something else. And in the phone trips / wide web website and doorbells, the tandem stacking tutorial he has up there talks about Youngstown, Ohio, which I drove through to get here. And of course, I paid homage to the tandem on the way. But that particular tape shows how you stack tandems. This only worked on #1 crossbar switches. Those are 2-wire tandem switches, not the 4As, which are 4-wire tandem switches. It's these O codes that I did a lot of exploring. You found a whole lot of interesting things. 914-052 start. Beep, you get into the AT&T conference bridge. At that point, you can use your touch-tone telephone to make calls. You dial #4, you get a dial tone, a different kind of a tone, and you dial area code and number, and you'd hit actually the pound area code number star. And that was equivalent to a key pulse and start. And then you did #3, and you get another guy on the line, and then you dial his number, and then area code star. And then to get them together, you do #5, and that would tie them together.
John, we're
was
going to
the-
have to bring you back for a whole session on this next year.
Anyway,
At-
that's
at
how it
next
all
talk.
works.
But
So you were
we're
talking
running,
about
we're running
Oak
down on
Codes,
time. We want to get a couple more questions in. Thanks. Yes, go ahead.
Okay, great work with the Blue Box tones. Any thoughts about ACTS in the future and making it Redbox compatible as well?
Any thoughts about what?
ACTS tones.
Oh, you're talking about redboxing
Yeah,
now.
I've got a payphone in my living room that just is begging for it.
Yeah. Actually, I'm not aware of any functionality in Asterisk that could actually decode the automated coin toll system tones, but it's not to say I couldn't write it.
Well,
There's really the good thing about me developing this project is I got to really dig into the internals of Asterisk, and I feel pretty confident at this point in being able to make it do pretty much anything I want it to. But that would be a cool idea, actually. For anyone who's not familiar, up until the late 90s, it was possible to make free phone calls on payphones by mimicking the nickel, dime, and quarter tones, which were a different sequence of tone pairs, in order to simulate the insertion of money into the phone. And this could be used to obviously circumvent toll charges, basically. This was done by a large number of people. In fact, if you were here for the talk before, Ed Bernie S. was actually prosecuted for possessing such a device that was used for this purpose. Yeah, next question, please.
Hi, I'm an Asterisk developer. I've been doing low-level programming for about a year, and I'm also a contributor to OpenPBX, but I wanted to tell you about a new project called FreeSwitch, freeswitch.org, and specifically, FreeSwitch has a feature called Teletone in the Red SpiderMonkey module, or Mod SpiderMonkey module, which is JavaScript. And you might find that very interesting to know about that because you can program in JavaScript, and it's fully asynchronous programming to design this type of thing. Lynn, if you worked in Asterisk, you know it's kind of hard to deal with some of the codes. Even the app dial function is 17 pages, I believe.
Yeah.
It's terrible. I quote Beavis and Butthead, you can't polish a turd, so.
Asterisk, yeah, has been around long enough that it's kind of turned into the kitchen sink phone system. So there's a lot of cruft left over from years of just like slapping stuff on top of it. But I'll have to check that out. Why don't you come up after and we can talk about it more?
Absolutely.
Thanks.
Freeswitch.org.
Okay, yep.
That's it. Okay,
We're out of time. I'm sorry.
we're out of time.